How many times a day do you put your trust in someone else with your money or your information? I mean, think about it. Your bank, your social media accounts, even the government. Our entire digital world is built on trusting these middlemen. But what if we could build trust without any middlemen at all? Well, that's the whole idea behind blockchain. And today, we're going to break down exactly how this so-called trust machine works.
I mean, really, stop and think about this for a second. Why on earth does it still take 3 days to send money to another country? And why do we keep hearing about these giant data hacks where all of our private info gets stolen? These aren't just random problems. They're all signs that the systems we're using, these centralized systems, have some major weak spots. And that is the exact problem blockchain was invented to fix.
All right, so to really get why blockchain is such a potential game changer, we first have to understand the problem it's trying to solve. And it all boils down to this one idea: our complete reliance on centralized trust.
So this chart lays it out perfectly. On the left, you've got the world we basically live in now. Centralized. One company, one bank, one server, it controls everything. But that also makes it a single point of failure. If it gets hacked or even just makes a mistake, everything can fall apart. Now look at the right. That's the decentralized model. Instead of one person holding the keys, everyone on the network shares a copy of the truth. There's no single weak spot, which makes the whole thing incredibly secure and transparent.
Okay, a decentralized system sounds great, right? But how does it actually work without a boss in the middle calling the shots? Well, it all comes down to a totally new way of keeping records, a new kind of ledger.
The absolute easiest way to think about a blockchain is just to imagine a digital notebook. But here's the twist. Everyone in the group gets a copy of this notebook. No single person owns it or controls it. Everybody shares it. And because they can all see the same exact thing, they all trust it.
So anytime something happens, let's say person A sends some money to person B, that transaction gets written down on a brand new page in this shared notebook. In the world of blockchain, we just have a special name for that page. We call it a block. Simple as that.
But here's where the magic really kicks in. These pages aren't just sitting there in a loose pile. Each new block is sealed shut and then linked to the page before it using some seriously powerful math. You can think of it like a kind of digital superglue.
And when you link all those blocks together, well, you get a blockchain. A blockchain. It's a chain of records. And here's the most important part to remember. Once something is written into this chain, it's permanent. It creates an unchangeable history of everything that's ever happened. Okay, I know what you're probably thinking. Unchangeable is a really bold claim. So how in the world does this chain stay so secure? Let's pop the hood and take a look. So if we were to crack open one of these blocks, we'd find 3 key things inside. First, you've got the data itself, the details of the transaction. Second, something called a hash. Just think of it as a unique, one-of-a-kind fingerprint for that specific data. And third, and this is the secret sauce, it contains the hash or the fingerprint of the block that came right before it. That's the superglue that connects the entire chain.
And that structure naturally brings up the most important question of all, right? What happens if some hacker comes along and tries to go back in time to change a transaction, maybe to try and give themselves a bunch of money they didn't earn?
This is where the sheer genius of the system really shines. The moment a hacker changes even one tiny little detail in an old block, the hash, that unique fingerprint, it completely changes. Now that new fake hash no longer matches the link in the next block. It's like a broken link. And that one little mismatch instantly breaks the entire chain. Every single block that comes after it becomes invalid. It's a massive domino effect, and everyone on the network who's holding their own correct copy immediately sees the fake, and the whole network just rejects the change. It's brilliant.
And as if that wasn't enough, there's actually another layer of security. Before a new block can even be added to the chain, a majority of the computers on the network, more than 50%, have to check the work and all agree that the transaction is legit. It's a democratic vote. We call it consensus, and it makes it basically impossible for any one person to sneak something fake onto the books.
So, we have this incredibly secure, decentralized record book. But the technology can do a whole lot more than just write down what happened in the past. It can actually execute instructions. You see, the blockchain isn't just a static database. It can actually run little bits of code, almost like tiny computer programs. We call them smart contracts. You can almost think of them as little robots that live on the blockchain and just follow their instructions perfectly, every single time.
So a smart contract is basically just a contract that enforces itself. The rules of the deal are written directly into the code. It's like a digital vending machine.
If you put in the money, then the machine gives you the snack. It's automatic. Smart contracts do the exact same thing for things like money or property or stocks, but with absolutely no need for a banker or a lawyer in the middle.
Now, I know this might all be sounding a bit like science fiction, but this tech is already being used to solve some huge real-world problems today, and it goes way beyond just cryptocurrencies.
I mean, just look at how versatile this is. In supply chains, you can track a head of lettuce all the way from the farm to the store to stop contamination. For luxury goods, you can prove that expensive handbag is real and not a fake. In healthcare, and this is a big one, imagine if your medical records were secure and completely controlled by you, not a hospital. And of course, in finance, you could send money across the world in minutes, not days. The possibilities are huge.
And this isn't just a what-if scenario. Take Walmart, for example, a massive company. They are using blockchain right now to trace their produce. So if there's an outbreak of E. coli, they can find the exact farm it came from in minutes. It used to take them days or even weeks. That is a real-world, life-saving application of this technology.
So the potential is obviously staggering. But does that mean we're about to flip a switch and live in a totally decentralized world tomorrow? Well, not so fast. There are still some pretty big hurdles in the way.
Yeah, we've got to be realistic here. The technology is still pretty young, and it has some serious growing pains. Scalability is a big one. Some of these networks can get really slow and clogged up if too many people try to use them at once. Energy consumption is another huge concern. Some blockchains use an incredible amount of electricity. And of course, governments all over the world are still scratching their heads trying to figure out how to even regulate this stuff. Which really brings us to the final multi-trillion-dollar question, doesn't it? The promise here is massive. A new digital world built on a foundation of pure, verifiable trust. But are these challenges, scalability, energy, regulation, just too big to overcome? Honestly, only time is going to tell. But one thing is absolutely for sure. The way we think about trust has already been changed forever.